In this video, we're going to discuss expanding and condensing logarithms. Specifically, we're going to use the product, quotient, and power rules for logarithms to both expand logarithmic expressions into sums or differences of logarithms, as well as, on the reverse side, condense sums and differences of logarithms into a single logarithmic expression. So in this example, we want to rewrite the expression natural log of x to the fourth y all over 7 as a sum or difference of logarithms. In order to do this, we're going to use the product, quotient, and power rules for logarithms as necessary and as dictated by the given expression. And so we'll start with just looking at this logarithm and noticing that inside the logarithm we have a quotient, x to the fourth y divided by 7. So we first apply the quotient rule, and this will give us the natural log of the numerator, x to the fourth y, minus the natural log of the denominator, natural log 7. The first natural log here is the natural log of a product, x to the fourth times y. And so we'll use the product rule on the first term. This will be the natural log of x to the fourth plus the natural log of y. And again, the negative natural log of 7 comes along for the ride. The first term here is the natural log of a power, so we can use the power rule to bring that 4 out front, resulting in 4 natural log x plus natural log y plus natural log 7. This is the simplest that this expression can get. We're taking the natural log of a single variable or a number in each case, and there's no way to simplify this any further. And so we've successfully rewritten our expression as a sum or difference of logarithms. For this example, we want to expand the log base 6 of 64x cubed times 4x plus 1, all divided by 2x minus 1. Again, we see that inside the log we have a quotient, so we can write this as the log base 6 of our numerator minus the log base 6 of our denominator. The first logarithm here is the log of a product. So we could use the product rule extended to 3 factors to write this as the log base 6 of 64 plus the log base 6 of x cubed plus the log base 6 of 4x plus 1 minus the original term in the denominator, log of 6 of 2x minus 1. The last two logarithms are as simplified as possible. So these two over here, these are as simplified as we can get because there is no rule for the log of a sum or a difference. But the first two can be simplified slightly. Notice the first one, we have 64. But 64 we can think of as 2 to the 6th power. And so log base 6 of 64, instead of 64 we can think of 2 to the 6th, and we can bring that exponent 6 down in front using the power rule. And so we get 6 log base 6 of 2. The second term we can bring down the exponent of 3 and get 3 times the log base 6 of x. And again, these last two terms come along for the ride. There's no way to simplify either of those. In the past two examples, we looked at how to expand a single complicated logarithm into a sum or difference of simpler logarithms. And starting here, we're going to start looking at the reverse process. Here we're asked to write the log base 3 of 5 plus the log base 3 of 8 minus the log base 3 of 2 as a single logarithm. So in order to do this, the first thing that we will do is look at the first two logs that are being added together, the log base 3 of 5 and the log base 3 of 8. We can rewrite that sum using the product rule as the log base 3 of 5 times 8. And of course, log base 3 of 2 is going to be subtracted from that single log. And of course, 5 times 8 is 40, so this is log base 3 of 40 minus log base 3 of 2. We now have a difference of two logs with the same base, 3, and so we can apply the quotient rule to obtain log base 3 of 40 divided by 2, which is the log base 3 of 20. And so this expression, log base 3 of 5 plus log base 3 of 8 minus log base 3 of 2, can be rewritten as the single logarithm log base 3 of 20. In this example, we want to condense the log base 2 of x squared plus 1/2 log base 2 of x minus 1 minus 3 log base 2 of x plus 3 quantity squared. And we want to write this ultimately as a single logarithm. And so, like the previous example, we'll go term by term and simplify. So the first thing that we need to do is deal with the coefficients that are in front of the second and third logarithmic expression. And we can use the power rule to move those coefficients up as exponents of the thing inside the logarithm. So 1/2 log base 2 of x minus 1 can be written as log base 2 of x minus 1 to the 1/2 power. And similarly, 3 times log base 2 of x plus 3 squared can be written as log of x plus 3 squared to the third power. Each of those can be simplified a little bit. Raising something to the 1/2 power is the same as taking the square root, so it might be more natural to write that as the square root of x minus 1. And squaring something and then cubing the result is the same thing as raising the original expression to the 6th power. And now we have 3 logs being added and subtracted together, and so we can apply the product and quotient rule from left to right. The first 2 terms are being added, and so we can use the product rule. So the first 2 terms would be the log base 2 of x squared multiplied by the square root of x minus 1. Minus log of x plus 3 quantity to the 6th. And now we have the difference of 2 logs. And of course, all of these, now that I see this, all of these logs should be log base 2. Over here, I simply drop that from the original example. And now I have the difference of 2 logs base 2's, and so we can apply the quotient rule. So we get log base 2 of x squared times square root of x minus 1 in the numerator, and in the denominator, x plus 3 quantity to the 6th. And so we have now used all 3 of our rules, the power rule, the quotient, or power rule, the product rule, and the quotient rule in that order, to rewrite or to condense this expression into a single logarithm. So another example here, we want to rewrite 2 log x minus 4 log x plus 5 plus 1 over x times log 3x plus 5 as a single logarithm. We're going to approach this much like the previous example. We're going to first deal with the coefficients in front using the power rule, and then use the product and quotient rule from left to right. So to deal with the powers, 2 log x will become the log of x squared by dragging the coefficient up into the exponent of x squared. The 4 log x plus 5 will become log x plus 5 all to the 4th power, again, using the power rule there. And the third expression, the coefficient is not a number, it's 1 over x, but that's okay. It might be helpful, actually, to think of 1 over x as x to the negative 1, be a little bit easier to write. It behaves the same way. So we'll have log of 3x plus 5 raised to the negative x power. Now this would be hard to compute. We do have an x in the base of this expression as well as an x in the exponent, but this is what we're taking the log of in this particular case. So this power rule, or even the product quotient rule, doesn't just apply for numbers, but they work for any kind of expression of the variable as well. Right? And now that we have logs added and subtracted, we can go left to right and apply the product and or quotient rules as necessary. The first 2 logs here are being subtracted, and so we need to use the quotient rule. So this is the log of x squared over x plus 5 to the 4th. plus the log of 3x plus 5 to the negative x power. Right, and now we're adding these two logs, and that means we want to use the product rule to multiply these together. So x squared over x plus 5 to the fourth multiplied by 3x plus 5 to the negative x. And of course, this would be perfectly fine, but we could go ahead and multiply all of that together and make a single fraction. So we're going to get x squared 3x plus 5 to the negative x power all over x plus 5 to the fourth power. And all of that sitting inside of a common log.